There we go. I gotta tell you, I, yeah, I didn't want to, or I was pretty reluctant to even start streaming today because I'm really unsure if I even know how to do this. But I'm gonna go ahead and save what I've done so far before I break all of this. Because I have done some good stuff so far. Let me see. Here. Let me make sure everything else works before I destroy this. Okay, so that does what it's supposed to. The panning, zooming, whatever. Going out of frame. That's fine. And the square. That's just a square, great. And I also want to make sure it does what it's supposed to do if I... Oh wait, the fill color... Oh yeah, I added this. Okay, so that's how it's supposed to look. Gonna take out the fill color. That gray doesn't look very good, but that is what it's supposed to look like. Okay, this is the square. I'm just gonna look over all of this before I actually break everything. I factored out the logic where I pass in the view and projection matrices, so that isn't done in the mesh itself. It's done externally, which makes a little bit more sense. Since the view matrix is from the camera and the projection matrix is from the renderer. I try to always pass the projection view matrices to meshes. And here, this is where I'm moving the projection matrix out of the mesh class. Oh, this shouldn't be commented though. These lines, all of these changes to the shaders probably just shouldn't be there. Well, that's not quite true. Some of them probably should, but this shouldn't. This probably should not be there. And anything I commented. Where is this? Get GL position? Why does it say it's commented in the change? Oh, this is the one from inserts. So this one? Yeah, this shouldn't be commented. Passing in the projection matrix, that's correct. These three matrices is correct. The point and unit normal. Okay, these are just moved down and I made them four-dimensional. These lines are... Okay, this is just adapting for the point being three-dimensional, so that's right. And some changes so that I can optionally return matrices without formatting them. Anyway, this is all stuff I want. So let's say modifications to matrix code. I'm converting, let's just say attributes. Let's just say attributes. Great. With that, it can get into the very confusing stuff. So here's the status right now. Shaders are supposed to be transformed. They're generally transformed by means of a model matrix and a view matrix and a projection matrix. Similarly to if I go to the default shader. This one, pretty much just like this. Now the shaders that are already written in the library do not do this. Which means I can't transform them with the camera. At least not in the same way. Not in the same way that these axes get transformed. Which is why the square isn't doing the same thing. So, I'm going to try, starting from the fill, to transform the already written mobject shaders with the transformation matrices that I'm using with the other meshes. So I have to add a fill opacity. This is the only way it'll use a fill. And I'm going to try to edit the fill shader. The problem with this, I've done a little bit of this. And this is the way it's done currently. These functions position point into frame and rotate point into frame. These functions are just written by hand, which is not that great. See if I can find it. Yeah, these. So this is reading data from the camera and then just manually translating, manually rotating. It's not clear to me how this is rotation. I guess it is using a matrix there. Maybe I could use that one. But what I want to do is multiply by just a model view and projection matrix. This will not work because the projection matrix, the logic for the projection matrix is hard-coded into the shader. So I can't, even though I'm passing in a projection matrix, this one, I can't just multiply by the projection matrix here. Because that logic is being recreated in the geometry shader. Basically this getGL position function. So I can do this much, and actually this does move the fill of the square relative to the camera a little bit, which is a little confusing to me why it even does that. Well, I guess that data is encoded in the view matrix. It might be sufficient to just leave this way. Well, not really. It'd be sort of nice to just leave this and just never multiply by a projection matrix. But the getGL position function has a lot of hard-coded data. Like, for instance, it's hard-coded to 16 by 9. You can't resize your screen, no matter what. And also, it doesn't make a ton of sense sometimes. Well, like this perspective scale factor stuff should just be done with the matrix. So what I'm going to try to do is unravel the logic from getGL position into something that can be encoded into a matrix. So most of the logic is going to be from this branch. It's going to be from this branch. So I'm going to try copying this over. And hopefully the result will be that I can factor this out into something which is similar to a projection matrix. And then I'll see if I can bridge the gap between those two. Hopefully. Okay, so get GL position is going to instantiate this result. The points are usually not fixed in frame. So do both of these transformations. Perspective scale factor. I'm not sure how this works. And I get the feeling that it doesn't work in a... It seems like a one-off thing. Because is this question like, is there a better way to do this? Which seems a little janky. So I'm just going to say GL position equals this result. And then I won't call it here. And I think this should do the same thing. And it does do the same thing. So now I have to figure out how this works as a matrix. For one thing, I'm not even sure how to declare matrices in OpenGL. Matrices are floating point, single precision, or double precision matrix types are as follows. In them can be the numbers 2, 3, or 4. We're going to be looking for 4x4 in columns and in rows. Swizzling doesn't work. That's fine. Okay, and when you index a matrix, it's indexing a column. Okay. So what's the formula for x in this function, or in this piece of code? Well, it's going to depend on what happens with perspective scale factor. So I think I have to unroll this too. Although it's only one line. And I happen to know that this focal distance variable is just a 2. Yeah, from perspective uniforms, it's just camera.get focal distance, and this is a... Oh, maybe it's not. Camera.get focal distance returns self.focal distance times the height. So the focal distance is 2. I'm not sure what the height is. What I should do is just print this and not worry about what it is. Just so I can copy it. And it broke something. Z. This Z variable is result.z. Okay, so that does the same thing. Same thing I was doing before, and 16 is camera.get focal length. Get focal distance. What is the focal distance? You should remember this from the lens tweet. Focal length. Okay, I don't know. A measure of how strongly the system converges or diverges light. Okay. I guess the point of that is if you adjust the focal distance, it'll affect how much the camera zooms when you scroll. At least that would make sense. Okay, but now... that's a 16, thank you. Okay, but now... that's a 16, thank you very much. I'll actually... I'll just replace this with a 16. And this. So that'll just make it easier to unroll into a matrix later on. And let me go to here. Okay, so now I think I'm going to have to turn this into a matrix multiplication. Which means I'll need formulas for each of these, but honestly, PSF, this max, why is this here? The max of 0 and 16 divided by 16 minus result as z. And if that value is positive, then we multiply the result by xy. I wonder what this is. 16 divided by 16 minus z. I guess one way to find out is just change it from 16. So I make this, I'll let that one. I'll make this a 10. The square got smaller. It's also not translating by the same amount. I guess I can deal with that separately. But I wanted it to actually be... I wanted the square to be larger. Because the red plane here, that's 1 by 1. And the square is also supposed to be 1 by 1. I think. If I go to OpenGL Geometry. Oh no, its side length is 2. So that's even worse. Which is more difficult to start from scratch or from a written code without documentation? It depends on which code you're talking about. In the case of shaders, it's much easier to start from scratch, usually. Especially, Grant wrote these in a non-standard way, so I have to like reverse engineer what he was thinking. But the square by default has a side length of 2. And the red plane here, the XY plane, is also has a side length of 2. So the fill needs to be larger. So I need a value higher than 16 here. I'm going to try 18 randomly. Just to try to find something that makes it fit. Now it's not getting any larger, which makes me think maybe it's hitting that maximum. The max of 0, and... what I think I'll end up doing is just taking off this maximum. Because it looks like... was it getting larger? Maybe it is, actually. It looks like the purpose of this was to prevent things from getting clipped off the edge of the screen to keep vertices too far out of frame from getting cut. Maybe it's not. Because, for instance, when these axes get too close to the camera, they disappear. And maybe it's trying to prevent that from happening. But that's supposed to happen. Max is 0. It looks like I can't... It's not clear to me that there's a reasonable value of... Max is 0. It looks like I can't... It's not clear to me that there's a reasonable value of this that'll make the square fit the other square. Like, when it's up here at 50, it seems like maybe something's going wrong. Maybe this isn't the right way to do this. Or whatever. I'm just going to try to reverse engineer it the way it was with 16. Even though that's too small. And I think I'm going to get rid of this max. I think that'll just be too confusing. And whatever the problem was with things getting too far out of frame, I think I'll just have to deal with that. It is pretty unsatisfying that these are translating at different rates, though. That's pretty bad. If you ignore the stroke. I haven't made any modifications to the stroke yet. And I guess that's something to do with the view matrix? I guess it's hard to tell from right now. But okay. I'll just remove this line. And what's the formula for result.x? That's what I'll need. I think the answer is result.x equals, there's itself, it's result.x times this well, like the input.x times this thing, and then times this PSF value. This value is only if it's greater than 0. Why would this not be greater than 0? I guess if the z coordinate is too large? And what happens then? Let me see. So I can make the z coordinate larger. That would be by zooming out. Okay. That's how it behaves then. And I'm just going to try doing this unconditionally. Just always multiplying with this PSF. And the reason is that matrices can't do this if thing. Like if whatever is greater than 0. And that sort of works. It's still scaling and moving at a different rate than the rest of the mesh. Kahian? I guess I don't know how to pronounce that. Well, thanks for following. And that could be tricky to track down. I might end up actually asking Grant how this works exactly. And maybe that'd be helpful, maybe. But after these two transformations, then it'll be, all the coordinates will be mapped to the coordinate space of the camera. So when they're passed to the geometry shader, here, all of these transformations are being done in the camera's space. So index 1 minus index 0, index 2 minus index 1. These things are all being done in the camera space. Maybe it's possible to just... These things are all being done in the camera space. Maybe it's possible to just convert every vector, all of these data points, which there's not too many. It's basically only the Bezier points and the normal. But maybe it's possible to convert all of these into clip space before I do the calculation. And if I do that, then when these vertices are emitted here, I could just remove all of this logic, mapping it into clip space. But that'd be sort of a lot of code. I'll just try doing this for now. So it's PSF. Okay, so times 16 divided by 16 minus Z. So this is the formula for X. So take X, multiply it by this, and then multiply it again by that. And this and this. Which looks like a strange way to project the X coordinate. Normally in a projection matrix, this is how you would project. Either like this, or I think there's a, or like this. This perspective projection. Is this also... Okay, this is also the perspective projection. Right plus left, right minus left. This is basically the width of it. I guess this is similar to what's happening. 2 divided by the frameshape.x. Is that this? What's n? Oh, n is the near plane. But the right minus left, that's the width of the frame. So it is being multiplied by this. But it isn't being added to this, whatever this quantity is. Which it actually doesn't need to be, because if it's symmetric, which it is in this case, it would be this computation, which it's also not following, unfortunately, because this is 16 minus 16 divided by 16 minus z thing. Let me write it out for y. The y coordinate is multiplied by frameshape.y. And then it's also multiplied by this thing. Okay. In the example, in the shader Grant wrote, as well as the documentation I'm looking at, the x and y coordinates are only multiplied by one thing. So maybe that does make sense. It's just that whatever math he did, I think he did to cancel out the near and the far planes. The z coordinate, on the other hand, I'm not sure if it makes sense. The z coordinate... Uh-oh. Oh, there we go. My keyboard just disconnected. Okay. The z coordinate Oh my gosh. The shortcut that I had for making my keyboard faster isn't there anymore. But it's Z, it's multiplied by 0.01, and then it's multiplied by -1. And that's it. X and Y are multiplied by this PSF thing, but Z isn't. It's